Welcome to our webinar today. We are here with Fabio Hassler.
Yes, warm welcome also on my side. I'm glad you here today.
Excellent. Have video last week, completely new here in the front. Hopefully, then we won't have as sound problems. So keep us posted with your feedback on the new camera, lighting, everything that we've got set up here. So, okay, we have prepared some slides for you guys today. Jump into the product camera to look at a few of the products in detail. Don't forget to type all of your questions in the chat. We will see those and can answer them right away, hopefully.
Of course, yes.
Okay, so let's get started with our PowerPoint presentation. We'll jump right into that now. A little bit about the agenda that we have for today. Okay. So here we go. Now on the next slide we have the agenda, and this of course is what we're going to be talking about today. A little bit about the technological.
It would be technical today, but I will also lay the focus on marketing actions and success stories, of course.
Absolutely. Then of course we're going to talk about the solutions, what we offer in this world of suppression technology. All of our key buying facts we'll summarize for you, and then talk a little bit about solutions and give you some examples, and then of course what for the future.
For the future, yes.
All right, sounds good. So why don't you go ahead and start and tell us a little bit about when do we need suppression?
Yes, of course, I would like to start free from my mind. So we know EN electronic control is becoming increasingly more in control engineering today, switching contact motors and also valves is penned with. So disturbances that can occur in the interaction of components can considerably impair the function of electronic devices installed in our machines and in our system. Especially the question of why it is important, I would say. We all know Lenz's rule and also induction law, which is current flow, and of course magnetic fields. And especially when switching on and off some inductive load, so to speak, the voltage arise up the volt range, so it's a real problem, and voltage peaks can occur. So
absolutely,
these are significantly higher than the actual nominal voltage of our consumer, and this can lead into contact fires, for example. And I would say because of this, the suppression of switched contactors is therefore still an important topic.
So what is exactly a voltage peak?
Yes, let's talk about the voltage peaks. They are the core problem in this whole thing, I would say. So yes, voltage peaks, in my description, I would say are short-term high voltages that can exceed the permitted value of our consumer installed in our machine. So it could be really a multiple of the nominal voltage value.
Okay.
I have an example. I think relays, also light bulbs can be an example. And yes, it arises then when we are opening a circuit, inductive consumer installed. Also with an operating circuit breaker which trips, it can also occur. And as an example, I can already name coils.
Okay.
We always work a lot with coils in the industry. And yes, like I said, the voltage peaks can always occur and inductive consumers, and therefore the main reason is the self-induction, like we described in the self-inductive law, I would say. And yes, that's what I say about voltage peaks.
Okay, so now we want to talk a little bit about why exactly they cause problems. So we're going to go a little bit into the physics behind the phenomena here.
Yes, behind the phenomena. So attention please, it gets a little bit technical now. So first of all laws do not lose their validity today. So Ohm's law is always and everywhere, just like Lenz's rule. I try to speak slowly that you can follow me. So I would say the effect arises from the fact that a magnetic field is generated around an electrical conductor. So in particular, we have a coil again during his operation or during its operation. So when the circuit, my circuit, is opened now, the magnetic field collapses. And at this moment induces a voltage in this coil. So by breaking down the magnetic field, the magnetic energy is converted or is getting converted into electrical voltage.
Okay.
So this occurs because the current in the turn of moment will flow through the coil in the same size and in the same direction. Yes, it continues flow to the solenoid. Yes, I can say, for example, relay, valve, motor, of course, also conductor. And yes, so the coil continues to drive the electricity. And this is one of the main problems. So the coil becomes becomes the source from the consumer and supplies this power. So I would say also the energy from the remaining magnetic field, which decreases, is generating, as I said, this current, and this current cannot flow because we have an open circuit or off circuit, and as a result, we have traffic with the current, and the voltage peak occurs in this moment in form of a contact flashover. So the self-induction throughout the process and voltage could, of course, jeopardize equipment and electronic components connected in this conductor.
Excellent. So here we're really talking about basic physics laws, and
like they already exist since hundreds of years,
millions of years.
Yes.
And I think so here we're really having the problem when that magnetic field breaks down, that the voltage has nowhere to go. The current has nowhere to go,
and
then
yes, of course, a lot of traffic and a lot of tension, of course. And then.
So tell us a little bit about what problems are caused by the voltage peaks, the requirements for suppression.
Yes, voltage peaks, of course, cause confusion in machines and customer systems. So problems, we can say, or we know it from our experience, are often not assigned. So customers say so beautifully in the machine it spits, and yes, the negative effects that entails are innumerable. So for example, we have failure of nearby consumers who work with lower voltage or lower energy. We have mechanical problems. We can also see with our own eyes, like contact burns and flashovers often appear. As I said, they are visually recognizable. So we have black contacts because the switching contacts are burning off. The electronical conductivity is reduced, and sooner or later the switching contacts aren't working anymore. So we have problems with life durability. Also, general malfunctions of sensitive loads and in our system can appear. We could have problems with signal transferring in our bus system. We can have incorrect data transfer and
tons of different effects.
Like I said, they are
innumerable. So really lots of different situations.
Especially, I would say, are the most critical problems, and I will say these problems do not lose in their validity because we have the time age of IoT and more digitalization. So I would say a control process should never be disturbed. And what I can say, what are the conclusions out of it, is that yes, the effects are not only annoying, they cost, of course, real cash money.
Yeah, exactly.
And this is what we have to avoid, of course.
Definitely. Okay, so let's talk about how we can create a solution or achieve an excellent suppression application.
So yes, like I in the slide before said, the problems are also the requirements we have to solve in our machine and in our system. So yes, fault-free system and
Yeah.
fault-free machine. And also we want to reduce the sensitivity sorry, of systems and machines regarding to faults. So I would say in general, the main criteria is to reduce and to damp these voltage peaks,
Definitely.
which can always occur. So because of the physical laws, yes, we want to have a correct running bus system. We want to increase lifetime of contactors, of motors, of valves.
Yeah.
And of course, also to security criteria, we want to increase the security and ensure operational security. Also in customers' mind is always guidelines, EMC guidelines.
Yeah.
So these are important for a CE conform machine or CE conform system.
Definitely. Okay, so let's talk a little bit about how we correct these errors. So how do we solve and then avoid the voltage peaks?
We have a solution for all our customers there outside who are causing these problems. So yes, the demands are resolved by decommissioning for a little money, for a little effort, of course. So because we don't have a universal solution, or we can't cheat on the physical laws in a concrete kind of way. So what can we do else? Corrective action, I would say, is provide protective circuits.
Okay.
Or like we do with the more electronics, say suppression modules, suppression, interference and suppression technology.
Okay.
So yes, of course, I would say suppression technology is suitable for all kind of consumers, like valves, motors, contactors, and our protective circuits include electronic components, like we all know from since years, diode, capacitor, also resistor, and they as protecting the consumer from these voltage peaks in a way of its functionality. So as a suppressor circuit is designed to reduce the voltage peaks when switching off our inductive load we are speaking about.
Right.
Yes, I would say the protective circuits are always could be produced an LED indication to have an overview about the system state. And yes, the induced current can always get freewheeled by a freewheeling diode in the most simplified explanation. So to connecting a resistor in parallel makes the solution in every kind of way, I would say. And yes, I would say the functionality can be roughly summarized. When the elements are conducted, they build down the electromagnetic field parallel to our consumer.
Exactly. Okay. So now let's talk a little bit about what we offer and a little bit about the Murray Electronic history with these products, because this is really how we started.
This is how we started. So I think everybody maybe who is with the Murray Electronic since many years knows the story from our Mr. Franz Habner, who is the father of the Murray Electronic. So back in the years, he designed this suppression technology as first Murray Electronic products in its own garage by using these electronic components, soldering them together, put them in a yogurt cup, and then let's fill in the mold.
Right, and then started to mold it.
It was one of our first. This was our first product. This is like we started. So
exactly.
Yes, for many years, Murray Electronic has been offering such protective curtains in our portfolio, and we always want to supply the right interference suppression for all common inductive consumers we know. So the suppression modules are optimally placed in close proximity to the source of the interference, so always suppress there where we have the interference. And we ensure that in a turn-off moment, the induction will not have so much impact in our system and in our machine. So Of course, our modules are designed in a wide variety of applications.
Exactly.
Like I said, we're talking about contactor, motor, and valve as well. And we also offer some universal modules. They are not fitting for a special component. They will fit universal where we need it.
Okay.
Also maybe like in a terminal box or something like that. And yes, like I already said, we speak about the first electronic products here.
Definitely.
And they are still in our minds.
Definitely. So let's take a look at the next slide, an overview. I'm going to ask our producer to bring the camera back up on our screen so that I can see that really quickly. Perfect. Okay. So Fabio, do you want to tell us a little bit about exactly what we have?
Yes, we offer in a wide variety, like I said, for, of course, switching component suppression, motor suppression, and of course, valve suppression.
Very nice. Should we switch over to our product camera now? Yes, we can of course
switch over.
Okay, sounds good. So we'll do that now, and then you guys can see that.
I was too fast.
You were too fast.
I was too fast.
It's okay. They know that you're still here. There we go. Now you guys can take a look. Should we start with the motor?
Yes, we can start, of course, with our motor. So I brought a little example. Yes, a normal AC DC motor. And as we can see here on the top, we have our terminal box where it should be easy to implement suppression. Like we have this cylinder form, like which we can implement here on top of our terminal box. I think the most sales guys know these products, and also we have the suppression we can place inside the terminal box.
Okay. Excellent. Now we have a second product that we brought with us.
The second product brought with us.
Switch it out really quick.
Yes, of course, for our high runs, the Siemens contactors. Yes, where we are offering, of course, a most suitable solution by implementing the suppression inside the contactor easily, of course.
So here you can see the solution right here.
Yes, it's here inside our contactor and shouldn't be, make any problems in form of installation or something like that. Excellent.
So those are a couple of the products that we have.
This was some overview about products, and of course I would always speak about valve suppression. We have pneumatic and hydraulic are doing great and important jobs in almost every kind of machine. So we are offering in our more electronic portfolio valve suppression, also valve suppression included in our MSUD plugs.
Exactly.
So for valves.
Yeah.
Also only like as for an easy installation option, the lightning little green one. I don't know a correct word at the moment for it, so it's a bit difficult for me. Talk about motor suppression. We have there also different types of examples on our slide. So examples where we can fit into the terminal box. We have modules we can place beside the terminal box, also by screw winding. Of course, also other high runners, the suppression and heavy duty motor connectors. Unfortunately, at the moment only from Harting. About switching suppression, about switching contact suppression, I can for all nameful contactor manufacturers like Siemens, Schneider Electric, Möller, Eaton, etc. We have a suitable suppression in our portfolio, which fit on perfectly on the needed contactors. So of course we are working close together with these manufacturers.
Very nice. Okay, so give us a few application examples and then how these applications should look with suppression.
Yes, of course. Suppression always makes their sense where I have a motor, motor application.
Okay.
This could be, motor circuit in form of pumps, in form of vents, very big vents, so ventilation and conveyor belts everywhere. So in logistics, airports as well. Also turntable applications where I use brake choppers.
Okay.
And in some kind of way, of course, they are most controlled by servo motors, but also I know some robot applications where, like I said, valve suppression everywhere where I have hydraulic and pneumatic automation, like in form of grippers, actuators, etc. Also, I would say in process industry, it would make a lot of sense. So these are some kind of examples, and of course, in the machines, in applications everywhere, some plant construction would be also makes sense.
Now you brought some pictures of how they look in action.
Yes,
so on
I
the
have
modules.
some suppression modules in action here. We can see right on the right side some motor suppression, of course, like I described in our halting heavy duty down below. Also with mounted cylinder suppression.
Okay, which picture is that?
Over the heavy duty.
Okay.
It's there. Also contactor suppression, so you can see a lot of contactors are installed in such a control cabinet, and everywhere where I have a contactor, I should suppress because these contactors are switching and switching and switching the whole time. And of course of this we have a lot of interference because the inductive law. Then in terminal boxes above, also another example I have with the motor suppression with the cylinder form. Down below another heavy duty example, and of course also the valve suppression in our great MSUD valve plugs.
Exactly. Okay. Now, Fabio, you have prepared 5 real-life customer examples. So let's take a look at the first one. This is the customer Hermle, and they are in Germany.
Yes, customer Hermle and customer Index are from the same business, I would say. So mechanical engineering, and of course I would like to prepare you out there some success stories, some about customers who really like to install and are really happy to have some suppression installed in the machine. So let's talk about Hermle and the company Index, which are producing some CNC machines, like also drilling machines. They are using a lot of valve suppression. They are using a lot of motor suppression, like we saw in the example before. Their suppress is the switching device installed in their control cabinet. It's in the most cases a larger contactor, and we have to suppress the solenoid here. Also, motor suppression, I think, for controlling coolant, how can I say it, coolant treatment, which are controlled by a pump, and also chip conveyors. Also, there with valve suppression are suppressing fluid units. We are installed a lot of solenoid waves. Why are they using it? So Index and Hermle are producing highly complex multi-spindle machines, and due to high quality machine availability, they cannot allow to have any EMC problems in their machines.
Exactly. So we help them with that. And here we have an annual sale of around about 10,000 units for both of those.
I think it could be more, or it will be more in the future.
Excellent. Okay, the next company is also a German machine builder, Alma, and they do control technology.
Yes, it's another business, but we can see our suppression fits in every kind of application. So yes, we have customer Alma. Alma automates fittings in pipelines, pipeline constructions, and supply engineering. And Alma has been developing and building electronic actuators and valve gearboxes for over 50 years now. And it's one of the leading international manufacturers of actuators today, and automated controls as well. So the electric or pneumatically or hydraulically driven actuators, for example, a valve to lock fluid flow into some pipelines, are used to control the mass flow of fluid in their technical system, and they are mainly used three-phase solution of motor suppression to increase the service life of encapsulated motor controllers. So they are controlling. Yes, they want, of course, to achieve a reduction of harmonics in their application by reducing the contact fires, which have always a bad impact on their bus system, like they described to me. Also, they want to reduce maintenance effort because these motors are installed far away in the field, so access to the motors is very, very difficult, and so maintenance should be avoided.
That costs a lot of money as well. Now it looks like here we're doing around about 32,000 products a year.
Yes, it's quite a lot for these little simple products.
Excellent. Okay, then we have the next customer, Navratherm, and this customer makes kilns or so ovens for ceramic and glass.
Yes, so
products.
These are not a business, I would say. They're, like Mackenzie said, producing industrial ovens for ceramic and glass kilns. So yes, they also use a lot of universal suppression from us. For power supplies, like transformers, also has to be suppressed often for their Siemens contactors, so for the Siemens series range. Yes, and these contactors are doing a job in this oven by switching between load and control current circuit. Yes, they have a lot of rotary slide value pumps installed for heat treatment operations, and of course they are working in vacuum, so it's also, I would say, difficult application where we can allow some suppression, some interferences.
Okay, and here we're doing the annual sales around about 20,000 of suppression.
Yes, so they have some suppliers, and of course they are also buying some suppression modules from electronic.
Excellent. Now the next company that we want to introduce is our example number 4, DMAG, and they make cranes.
Yes, another very, I would say, interesting business. First, they are producing industrial and process cranes. Of course, they use a lot of motor suppression, so the over a job in these cranes by controlling the horizontal and the vertical movement, also the windings of these anchor, I can say. And yes, they also want to prevent the system failures, and of course they have a lot of requirements because they have a high winding speeds with their cranes. Also want to ensure high overload capacity and the large speed control range of these windings, and of course it has to be suppressed.
Absolutely, and have to make sure that everything is safe and working up there in the sky. And it looks like with them we're doing around about 6,000 units per year.
Yes, it's stable, but yes, I thought it was a very good, interesting business.
And our last example that we brought with us is CLAF, and they do beverage machines, refund machines if you have that in your country, and we work with them as well.
Yes, another great customer, I would say, or interesting customer, company CLAF, and yes, they're also using a lot of suppression. Also, of course, for the contactors, and so they are very interested in the Siemens suppression because we have a 1-to-1 replacement for the Siemens parts. And yes, also they're doing a great job by switching the contactor, switching between load current and control current in these winding machines.
Perfect. Very nice. And so it looks like we're planning their 30,000 units next year with them.
Next 2 years.
Next 2 years.
Next 2 years.
Sounds good. Okay. Coming to the end, so Fabio, why should people buy from us? Why is More Electronic the right partner for suppression?
Why is More Electronic the right partner? So yes, like I already said, we are a pioneer in this business. So like I said, we speak about the first products here, and we have a lot of know-how built up over the last, I would say, 30 years. So we are also in this technology, the absolutely technology leader. And of course, it's a cheap and a very efficient way to achieve EMC correct installation. We're offering great and very high variety of different and optional mounting ways. And of course, I would say customers should put trust in our know-how and should benefit from our know-how. Yes.
Absolutely. Now, I think it's important here on the next slide to talk a little bit about the competition and also the sales.
Yes.
We don't really have a lot of competition in this area.
There are not a lot of competition in this area. Yes, you're right. So we know some competitors.
Of course, yeah.
Like Lutze, we are producing also suppression technology. Also, we have the company incubators because they are producing walls.
Okay.
And so on. They are only producing wall suppression. And yes, also we have some competitor in the Asian market, like the company Okaya, but all of these are producing suppression technology, not in this range. We are offering the suppression technology to customers, and also on the Asian market, we can capture this business throughout of a good performance of our Asian sales representatives. And yes, I see a possibility for winning some more suppression business by contacting directly motor manufacturers.
Yeah, that's a good idea.
Valve manufacturers, because so they also know this problem, of course, and they can provide for their customers a solution one out of one hand, I can say.
Okay.
And yes, I think this thematic isn't losing in their meaning. So like a wireless networking connections, networking system are increasing and also have to work, of course, very successfully. Also, they are very sensible due to interferences. And yes, especially customers who have recognize these problems and understand these problems should be a good opportunity to take the business with them. So I would say we should hold the level of 8 million euros per year, but I would say it should grow about some more 100,000 euros the next few years, or the next year, and then the year after another 100,000 more.
Absolutely.
And I think we are quite doing a good job, or well job with
excellent. Yeah, because you said in 2017, you wrote here, we sold 5.1 million pieces, so quite a lot. Really a lot of pieces.
Very well. So if we can take a real comparison to our other products, because these are more simple, more inefficient in producing. So this is the problem.
Right. Very nice. Okay, so Fabio, last slide from you today. Tell us a little bit about what the future holds.
Yes, last slide. Of course, I want to give the outlook to the future. So I think this technology isn't so complicated that there have to be more and more changes in future. But some things we can improve with More Electronic is, I would say, especially suppression in every motor connector. Makes sense. Of course, it is a benefit for customers. They can easily install it. They also have a good replacement opportunity in case of engine failure or something like that. Yes, why not working with the suppression in our M23 at least?
Yeah.
And why not changing the suppression in the heavy-duty connector from, unfortunately, at the moment, a hardening connector in our yes, modeling heavy series. We have also a lot of variants we can offer then. Yes, this would be a great opportunity, and I think that's no problem to start something like this approach. Of course, it has to be evaluated by sales, by the R&D, of course, and
make sure it's feasible.
These are some visions I had.
Very nice. So some exciting possibilities. So excellent, Fabio. Now you guys have time to write any of your questions into the chat. This is our last webinar for 2018. But we want to let you know that Fabio will be coming back with the suppression series next year in 2019 with 2 more webinars, the next one being EMC filters, and then, of course, EMC-like installation.
Yes, I would like to talk, of course, about EMC correct installation in form of wiring with shielded cables, and yes, also about grounding styles, of course.
Yeah, definitely. So we'll be back in 2019 with those. We can turn our PowerPoint presentation off now, and I think we have one question here coming in. I heard years ago to get safety standards in machines, you need some points, many of the TINA points. Can you use this from suppression? Are you familiar
I know some security standards of machines which we can increase by using different technology. Also, we can improve this table in form of the points by using EMC filters. Also, we can get some points in our machine for correct wiring, and so I think if I have EMC correct installation, like you said, to win some points in this case, we should use all of these, so suppression, filtering, and also EMC correct installations.
Very nice. Excellent. Okay, you guys, then if you don't have any more questions, we just want to thank you from our side for joining us today on this topic of suppression.
Yes, it was the first webinar, or not first webinar, but first product related webinar.
Yeah,
so
product related.
I did some technical webinars for our technicians as I was placed in the global sales support.
Exactly. So now you're here with your products, and it's really nice to have you with us.
Yes. Thank you a lot.
Okay, you guys, we want to wish you all, of course, happy holidays, a wonderful new year.
From my side too.
I hope you guys can really enjoy some time off, relax, and spend time with family and friends. And we will see you back here in 2019. Thank you so much. Take care.
Bye.
Bye.